So thanks everyone for joining today, and I hope everyone is having a great week. I'll quickly introduce myself before we get started with the session. I'm Twisha. I'm a part of the research team at CoveTool, and I work as a computational designer. My background is in architecture and computational design, and I've been working with CoveTool for over a year now. So um, today's session is going to be about how we can create workflows to avoid design revisions while using Rhino and Grasshopper as your main modeling, 3D modeling platforms. And throughout the session, please feel free to drop in your questions via the question and answer section in your Zoom window, and we'll make sure to go over them towards the end of the session. Also, before we dive into the details of the webinar, I just have a quick heads up that a couple weeks back, we introduced a new version of the plugin that helps you upload your Rhino and Grasshopper geometry to CoveTool. It is the geometry upload process, high level is pretty much the same, but there are some improvements. We have additional geometry categories, some exciting functionalities, including the ability to view daylighting results within the Rhino environment. So that's definitely something to look out for, and make sure that you download the latest plugin from the App Store. And we will definitely be covering this throughout today's presentation as well. So coming back to the topic for the webinar, how we can create workflows to avoid design revisions, and while working with Rhino and Grasshopper projects, this is what the agenda looks like today. So we'll get started by looking at what exactly the problem is, what are some difficulties that currently design stakeholders face while collaborating on projects, how we can work in a setting which allows for better collaboration. Then we'll go over what are some analysis types that are done throughout the life cycle of a project, responsibilities of stakeholders when they generally hop onto the project team for completing their responsibilities and things like that. And then we'll start looking at how exactly you can upload your projects to CoveTool, how you can set up your geometry, and then be ready to do integrative design studies on CoveTool. Later on, we'll also be looking at some comparison studies, how we can optimize building performance, and then we'll have some time towards the end to take any questions that you might have. So with that, let's get started. So what exactly is the problem that we're currently looking or seeing in the current industry? The first one that comes to mind is design and analysis are typically standalone workflows, and teams need better engagement. So there is one team that's constantly working on improving the design throughout the design phases. And then the analysis teams are something who generally work as consultants or things like that, which are brought in. Firstly, they're brought in like at later stages of design, and there's no cohesive collaboration that is seen between these two teams. This is one point. Another one is projects tend to go over budget, and efficiency needs to be baked in. So in an ideal situation, projects efficiency would be integrated within projects so that we are always up to date and are constantly thinking about the project targets that we want to achieve in terms of efficiency, cost, any other objectives that might be there. Compliance to new standards seems to be time consuming and expensive. So all the time, like every year or every couple months, new standards are like all standards are updated. Getting used to those standards and making sure that the design is complying to all these can really get time consuming. A lot of effort and time is spent on all these studies. And lastly, bringing in engineers at later stages of design makes collaboration difficult. And especially with Rhino and Grasshopper projects, it really becomes tricky to have engineers collaborate during the early phase or when the impact of design decisions is going to be maximum. So we'll be covering, like the focus of today's session is going to be around these 4 points and how exactly we can work with our design processes to get the workflow straightened out. So looking into this some more, we are constantly collaborating with all these different AEC stakeholders. We are constantly passing files. We are constantly communicating with them. But many a times this happens to happen in siloed conditions, and there's a lack of a software and a shared collaboration environment um, because when we're not working with these, there are unexpected cost delays, which can really be like negative, which can negatively impact the project. So there's definitely need of real-time coordination. We want to make sure that there's no loss of data while we're transferring information from one stakeholder to the other. When more stakeholders are brought in, that means they're using a lot more tools to complete their analysis, create project reports, and there's a lot of things that can be overseen, and things can just like um, uh, it's really difficult to keep a track of everything um, that is being coordinated within all stakeholders and through all these design phases. Um, every stakeholder has their own preference of using software, so the cost of software is divided individually rather than a shared platform, which allows every collaborator to cohesively work with each other. Now, how exactly does that analysis timeline look like? Who are the stakeholders? What kind of studies are done? And how much time does it actually take? So in the pre-design phase, which takes 1 to 2 hours per design option, um, we are generally focusing at preparatory activities. We're looking at EUI benchmarking, daylighting benchmarking. We would be performing climate and site analysis, so all these studies. Um, moving forward, we are then looking at how different massing options compare with each other, how we can optimize for the facade design, what window to wall ratios are working the best, and how um, we can better our daylighting within our spaces, looking into shading strategies, things like that. And then overall 3D analysis, which would involve daylighting studies, glare studies, shadow, sun hours, radiation, all those studies. And then in terms of energy reduction, we would be looking at high-level strategies that we could incorporate in order to have our EUI meet the target EUI. So, and in this stage, every design option would take 2 to 4 hours, depending on the scale of the project and other complexities. The design development, construction design, we would be looking at facade optimization, more strategies to reduce the EUI. Now we would be actually diving into the details, looking at what are the drivers, what metrics drive our energy use. If you're looking at certifications, this is the stage we would start preparing the preliminary documentation. And here, every design option would take about 2 to 6 hours to incorporate any change that needs to be done and to perform all the analysis and be up to date. And the time that's required to make design options goes on increasing as we proceed forward in the design development. So here, we have already completed a significant part of the design. Any design change would take anything between 2 to 8 hours. So all these activities are something that need to be done through the design phase, but definitely, like we know, if you're working with the traditional design process, the ability to impact cost and building performance is higher when you're making decisions early early on in the design phases. So this is the traditional design process in black, where we are looking at how design decisions are taken later on in the life cycle of a project, when the ability to make um, the ability to impact cost and building performance is lower, and the cost of this design changes is a lot higher. So we ideally want to be the ones who are working in the early design phases, are making decisions early on, so that we are being more efficient in terms of our time and effort that we are putting in. Um, Now, if you look at the whole building, again, life cycle of a project, there are some early investigations. You could either be looking at single aspect simulations, in which case all these analysis would happen um, like one by one instead of happening parallelly. And then that's in terms of daylight, but there's another aspect that we need to look into, which is energy simulation. So simple box modeling, and then going into design refinement, HVAC system selections, all these things. In an ideal situation, we would want to have design teams work parallelly to work on daylighting optimization as well as energy optimization. Um, Again, so bringing in those consultants early on so that designers and architects have a better understanding on how their design decisions are impacting the daylighting as well as the whole building energy analysis aspect of design. Um, so now, if you look at when stakeholders are involved in the design phases, we're looking at all these different stakeholders: owners, architect, contractors, MEP engineers, consultants. They generally, like if you look at the consultants, MEP, structural, civil, performance, they are still coming in later on in the design phases, which is design development. Whereas if they were brought in like early on, they would have a better ability to make impact to the design decisions. So um, it's not just about being like making stakeholders involved early on. There should also be a platform that lets you um, make all these design decisions holistically early on in the design stages. Um, and with that, I also want to take a look at how um, how Cove tool exactly can help, and how you can better work with your stakeholders, how you can start early on and make those impactful design decisions when you're in your conceptual design stages, when you're presenting your projects to your client. You already have um, a preliminary analysis done, and then you can continue working with your stakeholders moving forward, and making sure that your designs are most impactful. Um, on Cove tool for assembling an integrated team, the objective is that once you start a project, once a designer or architect starts a project, you have the ability to invite all these stakeholders so that whatever input or based on their expertise, they can provide feedback at every design stage as you proceed through all the stages of design. So the switching to an intelligent data management platform, and then making sure that there is improved access and easier collaboration, and reduces delays and costs in your project. So a contractor can, like an owner can invite, or an architect can invite the primary stakeholders, who can then invite further collaborators to make sure that everyone is on board, and then everyone is up to date on what design decisions are being made on a day-to-day basis. So how exactly would you do that? When you first create your project, um, there is a Manage Teams button on the first page, where you can enter in email IDs of project stakeholders, And everyone who you invite will have access to come in and collaborate with you on the platform. Based on the role that you're inviting the person for, depending on that, there will be access given to those stakeholders. For example, mechanical engineer or energy modeler can edit the optimization options page, can edit the baseline energy page, um, and so on. Like based on your role, you will have access to those pages. Now, not everybody you invite needs to be necessarily subscribed to CoveTool. As long as the project owner invites project stakeholders, they can easily come in, collaborate, and give their design inputs based on their expertise. Um, some more features for team collaboration. We have the inbuilt chat feature that can be found in the left-hand side pane. And then this basically lets you connect with the entire project team. You're basically connecting this entire project team to the single model, and team members can communicate directly in the modeling platform itself. So this is a great way to be up to date on who is making what decision. You can always chat within the platform and make decisions accordingly. Some more features here. You can always set the frequency of notifications when in the project there's a new change. There'll be a red dot that indicates a new message or a new update. You can always filter messages in this based on personal messages, external collaborators, manufacturers, or um, messages from within your team members. You can add lists, links, emojis, and attach files, JPEG, PNG, PDF, all these within the chat. And you can also reply and react to individual messages. So that's about how you can have your entire team onboarded and how you can then get started with making your project and uploading your CoveTool, uploading your Rhino or Grasshopper project to CoveTool. So before we dive into the details of how exactly we would upload or create a project, let's try to look at a high-level overview of what this workflow looks like. So you could be working with your project in Rhino. You build your project on Rhino. You reference these building components to the Grasshopper script, which is something that you can download from the CoveTool App Store, and then upload it. So once you reference your geometry, it'll be uploaded to CoveTool, to your project, where you can integratively collaborate with all your team members, make decisions on energy and cost optimization, and all the other features that are available to you on the platform. So that's one workflow where you have modeled the building on Rhino. There is another workflow that you could be following. You could be you might have an automated workflow for geometry generation. You might be using Grasshopper to create geometry. You can still use CoveTool's script to upload geometry to CoveTool. So you basically have that first step done. You could have another step added to it, which basically is for geometry optioneering. And then you can take those geometry elements, reference them to CoveTool geometry components, and still upload them to CoveTool. So you could be following any of the workflows, or you could have a modified version of one of these, but you will be able to upload your project and then get started with all the analysis that the tool has to offer. Now we also have an API. So if you're working with custom tools or platforms, you could still use CoveTool's API to upload your geometry to CoveTool. We have a robust documentation on our website. So if you're interested in a workflow like this, definitely look at that. And if you have any questions, you can always reach out to us via live chat, or yeah, live chat is the best way of getting in touch with us. So before we dive into the details of how exactly we would connect our geometry and get started, let's try to look at a few resources on the website. So this is the plugin and app store on CoveTool. Here you can find all the plugins. For Rhino and Grasshopper, you can just click on a thumbnail. You can find the latest version of the plugin right here. Plugin, when I say plugin, it basically refers to a script for multi-use, for uploading geometry to multi-use projects and single-use projects. In this case, for Rhino and Grasshopper. So for uploading geometry from Rhino or Grasshopper, you're basically utilizing a script that lets you reference your geometry from Rhino or connect your geometry from Grasshopper and connect it, upload it to the platform. We also have some installation and uninstallation guides here. And we have a video tutorial that you can always follow along if you have any questions or if you want to get started with the workflow. In addition to that, we also have a written tutorial that you can always refer if you have any questions. And this is that workflow. You can always take a look at that. Now, once you first log into the platform, this is the page you'll be on where you can create new projects, create new project templates, and organize your projects in flow folder. So you can do all those things here. What we would do right now is start a new project. So basically start a new project. That's going to take you to this page where you can basically enter details of your project, such as project name. You can have a project image, a project number. Those are optional. But the next step is to select the building types that you're working with. So if you're working with a single-use building or a multi-use building, depending on that, you can choose the building types that you want to be working with. And these are the default templates that CoveTool provides. So you could be using this, or you could also use any custom templates that your firm creates and reuse those for your projects. So right now we're going for a single-use office building. Once you have selected that, you enter the street address, or you could be using location coordinates as well. Once you do this, the energy code that's most relevant in that location is automatically populated for you. So what this does is, like, you chose the building use type, you chose the location and the energy code. All this information is then fed into the entire tool, and your baseline energy results are automated based on these inputs. So baseline engineering inputs would consider code minimum engineering inputs and give you that first EUI that you look at. But you can always come in, invite your mechanical engineers or energy modelers, make any edits to all those things. But the objective is that whenever you first log into the platform, all these things, you enter these details, you can always switch out the energy code. And the next step would be to upload your geometry. And you will then have access to all the features that the tool has to provide. Now, after entering this information, I told you about the Manage Teams feature and the chat feature. Those are located here. But we would basically click Save and Continue to go to the next page, which is the second icon right here. And we basically want to be following the order of these icons here. So now we are here. We can upload our projects using the plugin. And at this time, I'm going to go back to the presentation. So let's take a look at what the plugin workflow looks like. This is a high-level overview, but we will also be looking at the CoveTool script in more detail. So now there's 5 steps here. Once you open the single-use script, this is a single-use script. We have another script for multi-use. So once you first log in, the first thing that you do is enter your CoveTool credentials. So use the same email ID and password that you used to log into the platform. Once you do that, the second step is to enter your project URL and making sure that the project that is selected is the one that you're trying to upload geometry to. That's that. You basically select the project here. The second step is referencing all your geometry from Rhino to all these components right here. There is an error reporting box. So in case there are any errors in the geometry that you reference, those will be highlighted here. And then there's also a triangle count, which basically helps you identify the geometry components that have more complex geometry or have a lot of geometry that might cause trouble in getting uploaded. So that's just for reference. You just want to make sure that you are within the limits, which is 50,000 triangles. And that's all mentioned in this step. This step right here is, you don't have to do anything here. It's just to, it's giving you the results of energy use intensity of your project. And there's a small dialog box here, which would basically indicate success if everything on your project looks right. That would mean you can come back to the platform, continue with all the steps or all the analysis that you want to perform. Now, this fifth step right here is something that we recently added, and that is to bring your daylight results from Cove Tool back to your Rhino window or your Rhino project. So we'll go into all those details in just a second. The plugin workflow for multi-use projects is pretty much the same. It's exactly the same. You enter your credentials, log in. The place or the part where you connect your building geometry will just be repeated 2 more times. And depending on the number of use types you have, you can connect your geometry those many number of times to all those building use types. So that's a very high level overview of how the plugin script is organized. And now let's try to look at some best practice tips on how you can have your geometry set up and how you can export your projects to Cove Tool. So now we're back to Rhino. How would you set up your project on Rhino? The first step is to make sure that your units are set to feet. You can always change the units back. Like if you're modeling in metric, this could be your last step instead of the first step. So at the very end, you just go to the document preferences, change the units to feet, and then upload your project to Cove Tool. You can always toggle back between the units on the Cove Tool platform, but this is something that you do. The second step is to have geometry layers appropriately named. So in case you're already, of course, you would be having geometry layers, but intuitively, having layers that would easily help you reference geometry to the Cove Tool plugin is something that we recommend. So if you would basically have layers for roofs, floors, shading devices, skylights, interior walls, exterior walls, windows, that's just like a high level recommendation, but you could be following any other layer naming system that your firm already follows. The other step is to check for flipped face geometry. So we want to make sure that all the geometry that you're uploading is facing the right direction and all the face normals are facing outwards or upwards. So this step really helps in identifying those faces that might be flipped. You basically choose a really bright color as the back face color that easily helps you identify what parts of your project or what building elements might be facing the opposite direction. And you can quickly use the flip command to make sure that they're all facing the right direction. Some more tips here. You want to make sure that all your project geometry is unhidden. You have unlocked all your geometry components and your project is located near the 3D origin point, that is 0, 0, 0. In case you have below grade geometry that could lie under the origin, but the objective is to make sure that your project is close to the origin as close to the origin as possible. Why that's important is because that determines where your building will appear on the 3D page on your platform. Now, if you're working with a master planning project or just a project which is super dense, which has a lot of buildings that not all of them that you want to upload for analysis, you can definitely simplify it. Just make sure that you're having only the geometry that you're trying to analyze on Cove Tool in a single file. And that's just to make sure that you're working efficiently and there's no other lag that causes your geometry to be slow. Again, another thing to know or keep in mind is that whenever you're uploading projects from Rhino to CoveTool, you would want to make sure that all those are single surfaces. So in case you're working with poly surfaces or models with thickness, which you would be in case you are in the later phase of your design, you would want to simplify all that geometry, and here are some steps for that. So explode all geometry to convert to single surface objects. If you're working with groups, you basically select all groups and ungroup them. And then select block instance or block manager to eliminate all blocks. And just basically have single surfaces and clean geometry while uploading to the platform. Now, this can become really tricky when you have already developed your project, when you have already passed this stage where, or like if you're evaluating two ways of doing this, like one could be like you're already in the massing phase, you already are modeling with single planes and masses. It becomes super easy then to just explode and reference components to Grasshopper. But there could be another workflow where you're working with a complex model or you have already developed your design a lot, and exploring and simplifying may not be the best workflow in that situation. So based on intuition or like based on what you think would be quickest, you can either use this workflow that I'm suggesting to explode and reference surfaces, or you could just redraw a few components that might take a lot of time to um, explode and then reference single surfaces. So that's just something um, that we have to make a decision on. Um, and then if you're working with parametric geometry or meshes, that's something that you can also export to the platform. You would just follow these few steps, select the mesh, reduce the analysis mesh, and then convert it to a NURB surface before you upload it to CoveTool. So that's, you can always upload those kind of geometry types as well. Now, we have been looking at single-use projects until now, but what about multi-use projects? What about projects which have shared spaces, but use different system types, different mechanical strategies? So in this case, the steps that you would follow is on the first page, you'd basically select multiple use types, the ones that you're trying to upload your geometry or the ones that your building follows. The second step is to use the mixed use script and not the single use script. And you can find this script whenever you download the folder or the plugin from our app store. Then identifying the scope of each use, just um, just make sure to have a clear understanding of what use types would fall under which category. And then this is something that I follow right before I reference. I just select those components and color code them, but you could be following any system that you like. And basically you want to be referencing each of these spaces to every building use type. Now, what if there are shared spaces or what if there are geometry components that are being referenced in both these use types? The one thing to keep in mind is you only want to be referencing every geometry surface once. So in case there's a shared wall, you could either reference it in the retail use type or in the office use type, but not both. So that's just a high level um, workflow um, for working with mixed use projects. I think at this stage we can jump back to Rhino and Grasshopper and take a look at these in some more detail. Now I have my Rhino project open here. I'm working the single use script for uploading geometry to CoveTool. And so the way this is organized is anything that's blue or white is just something, it's just like a reference that you need to or it's basically feedback for your project. So the blue one is basically telling here the project that you have selected, and then things like that. So in the first step, the very first thing that you do is entering your project URL. And for that, we basically need to have this link right here from the first icon project page copied on your clipboard. So you can keep that copied, use that and paste it here. And that's basically going to reference the right project that you're trying to upload geometry to. You would have already entered your project credentials when you first open the script, because a dialog box would pop up requiring you to enter those details. But for some reason, if you want to re-enter those details, you can always click on this button to renew your login. Throughout the script, you'll see that there are some pro tips or just some troubleshooting guides in case you need any help working with the script. Now, the second script here, the second step here is to reference your geometry from Rhino. These are all the layers that currently you can reference geometry to, but the required layers are only roofs, exterior walls, windows, and floors. So as long as you have geometry in those 4 layers, you are good to go. All others are optional categories. This is the error reporting box. So in case you have any missing geometry in the required layers, or there's any problem with the geometry that you referenced, those errors will be listed here. And the total triangle count, that basically is giving you an estimation of how complex your geometry might be when you upload it to CoveTool, is given here. The threshold is 50,000 triangles. So in case you're close to that or you're exceeding that, that's something that's somewhere this breakdown helps in simplifying the geometry or just taking a look at what might be causing that increased triangle count. So the way you reference geometry here is, so you basically have your Rhino project right here. The one that I'm working with is a single surface model. So here, okay. So here I have these categories that I have already created. Anytime you want to reference geometry, a very helpful thing that I often forget and people might generally forget is to lock the solver before you reference geometry, because every time you try to reference geometry, the script will try to upload the geometry that you just referenced to CoveTool, which might not be the best workflow to upload geometry. So what you'd basically do is click on this component, right click, and say set multiple B reps. Once you do that, you basically go to your Rhino view, click on select objects. That's going to select all objects that are on the layer. And if you click enter, all those components will be referenced to these components. You basically go on following that same workflow for all these different components that you want to upload geometry to. And you'll be all set. You will, like once you have referenced all your components, you unlock the solver again, see if there are any error reporting messages, and continue with the workflow. So that's the second step where you reference geometry. And the third step is just to view the EUI results. These are preliminary EUI results. If you want to look at detailed energy results, you definitely would have to go to the CoveTool platform. This panel right here is super important because that's going to tell you whether there were any errors in the overall workflow or whether you're good to go with all the steps that you have done so far. The last step right here is something that we recently added. So let me turn this thing on. So basically, once you have uploaded geometry to CoveTool, once you have looked at the 3D analysis results, and let me show that step right here. So we connected all our geometry. We would basically just click refresh, and all these numbers would automatically populate here. That's when we know that our geometry has been passed on to the CoveTool platform. And a quick visual check to make sure that all the numbers look right is something that we recommend. And then you can continue to go to the 3D analysis where you can look at your daylighting results. Now, this is the building that I just uploaded. You can look at all these different kinds of analysis on the 3D modeling platform. You can adjust the grid size, the rotation angle, glass transmittance, and you'll see that not just the building, but also some context buildings are automatically populated. So that's all the that's something that we are getting from OpenStreetMap, so that you don't have to model your context buildings from scratch all the time. But yeah, that's how the workflow would look like for uploading geometry to 3D analysis to look at all these different kinds of results and make decisions on daylighting within your project. Now, once you are able to see these analysis results on the web app, that's when you can also bring them back to your Rhino window. What you would have to make sure is that the grid size and the rotation angle that is matching the one that you see on the web app. So you would adjust those. You can select the analysis that you want to look at. Um, you can turn off the roofs or just go choose a different, okay. Yeah, not sure why Rhino would do that, but basically, you can toggle between different view types um, and then look at the analysis results within your Rhino window. Okay, Rhino's acting weird, but that's the workflow. And on Grasshopper, you will be able to look at the SDA breakdown, the SDA results, and you can always choose the glare results as well, which is ASE. And you can select ASE, and it should momentarily just update the results to display the glare results right here, just like that. So that's like a high level overview of how you would connect your project, your Rhino and Grasshopper project, and upload geometry to Cove Tool. There's a few steps right here. So yeah, you can always like go to the wireframe mode that better helps you visualize the daylighting results. Like I mentioned, you'll have to make sure that the grid size and the rotation angle on the web app on 3D analysis matches the one on the script. So you want to make sure that those match. Sometimes if you like just uploaded your geometry and the analysis is just complete, you would just double click on this component, and then it will basically open up another script where you can recompute, and that's gonna like force to bring back the daylighting results. That's like a troubleshooting tip, which is also mentioned here. But basically, um, if you have any questions while doing this fourth step, that's how you troubleshoot. Just double click on it and it's gonna bring the analysis results on your Rhino project. And then you can always include those in your presentations, in any reports that you would create. Now, once you have uploaded a project to Cove Tool, there's some interesting things that you can may take benefit of. So on your project dashboard, once you have completed project analysis, or once you have run the energy analysis and the daylighting studies, you can select up to 4 projects and click this compare button to basically open those 4 projects side by side for comparison. And you could be comparing, so in this case, we're comparing the massing with respect to the energy use intensity, but you could be comparing anything. You could be comparing how different system types are working out and how they are impacting the energy use for the same project. Or we'll take a look at all the different kinds of analysis that you can do. Basically here, we have the project image, we have the project name, the areas for all of those, and the use types, and the window to world ratios in each of these cardinal directions. We have a breakdown of the EUI, and in case you wanted to compare certain use types, certain metrics, like heating and cooling, you can just have those specific ones in focus. And you can quickly look at the results from all these 4 analysis and make decisions on which ones you would shortlist or you would continue to work with. If you have completed daylighting analysis or 3D analysis for these options, those will also be displayed here. So in this case, the daylighting analysis is not complete for all options, but you would be able to compare those things here. Additional metrics here include utility cost per year, lead points that a project might achieve for energy and atmosphere or water efficiency, indoor water use intensity, and so forth. So all these are the things that you can compare for your projects. In addition to these, that you can also compare. So you could be comparing SDA and energy use intensity. You could be comparing massing and EOI. That was the example that we just saw. You could be comparing shadow and site analysis studies. So you can choose different times of the day and strategic times of the year to do those studies. And then facade and room optimization. So we have a facade tool which helps prototype facade designs on a shoebox model, which takes into consideration your project location and all the different cardinal directions and window to wall ratios in your project. And you'll be able to see real-time results or real-time impacts of your facade designs on the overall daylighting and glare within the project. So all these studies is something that you can do. In case you're working with a master planning project, you can also export that to Cove tool. This has been exported from Grasshopper itself, just as a reference. So what I did is we had all these, we just imported the envelopes of all the buildings that are here. And then we imported the outdoor floor as well, in case you want to bring in simple geometry context buildings or simple site elements that can be brought in. But as you can see here, like these are simple planes, like 2 planes, which were referenced in the shading device layer. The idea is that we don't want to increase the triangle count drastically, which creates unnecessary lag within the project. We just want to make sure that we are including the necessary elements that really impact the energy analysis in our project. You could also be comparing existing versus renovation projects. So you could model an existing project and a renovated version and look at how those compare. System type, this is something that I mentioned. You could be working with, or you would want to choose between different system types based on their performance. So you can have the same project copied multiple times, but just with different system types, and see how those results look like. In addition to that, design addition and comparison is also something that you can study. So you can also do benchmarking, energy benchmarking for master planning projects. The way you would do this is you would import a single building and compare it with all the others in the surrounding. For getting the energy benchmarks for individual buildings, this study is something that you'd have to do individually on each building. But that's something that you can always do and offer as a service to any of your clients as well. For especially while working with master planning projects, in case you wanted to look at the SDA results of a single building or the daylighting results of a single building and get the energy use of a single building in the master plan, the way you would do it is you would import all these floors or detailed construction geometry types for this one building, but all the other buildings are just envelopes and they're included in the shading device view. So that way you are able to view the analysis, like the detailed analysis for this one building, but you'll still be able to look at the radiation analysis and sunlight hours and all the other analysis that the tool has to offer on the context buildings. Now, we looked at 3D analysis. This is the facade prototyping tool that I was talking about, where you can quickly prototype facade options and look at how that's impacting daylighting and glare. Energy use page. This is a page which basically gives you that whole building energy use intensity number. All these when you first come in here, this will be automatically like it is an automated process. You'll already see this number when you first come in because the engineering inputs would be based on code minimum inputs based on the code that you select on the first page. You can always invite your collaborators to make any edits or you can make any edits. But the objective is that when you first come in or when you're trying out different design options, you're still following code minimum input. So even if you don't make any change, that's still going to be, you're still going to be complying to the code. But here is basically, you can also find the whole building baseline breakdown. And then once you have established the baseline for your project in terms of energy, you can go ahead to optimization and actually look at more details or look into more depth or analyze what product combinations can give the best energy versus cost results. Just a couple slides here before we open it up to any questions. So the first thing, whether you're doing analysis in-house or whether you're hiring consultants, is to establish like project targets. So is it reduced operating cost? Is it lower life cycle cost? Is it energy reduction that you're trying to get to? So establishing those goals and then being able to get to each one of them is something that we would want to do. And actually targeting each of those individually is something that is super time consuming, which is an extra effort, which we don't want to be looking at. So how can we do this in a more optimized way or a way in which we are always getting feedback on the design decisions that we are making? So a traditional workflow would basically involve design teams exploring impacts of isolated components throughout the design phase, and then looking at how that is. So for example, that would mean you'd be looking at wall insulation, then you would be looking at improving roof insulation, then HVAC and so on. So that is something that is happening that would happen in a traditional workflow. But in an optimized workflow, you would be looking at all these options and only choosing the ones that are actually meeting the energy targets or that are giving you those results quicker and without having to spend a lot of time on each one of those options. So the way you would do this is you would basically establish the baseline energy on the baseline energy page that we just saw. As a second step, you can add options to technology systems or products within the optimization page to make sure that you're considering the products that are most beneficial or most impactful for your project. And then the fourth step is to run the optimization to review all the bundles that have been created based on these options that you selected and find the best ones that satisfy all your project requirements. So optimization, when you're doing this, you would be looking at all these options that you have selected for envelope, for roof, HVAC settings, lighting, appliances, set points. In case you're working with energy generated on site, you can enter those details. And you'll basically be looking at the best combinations across all these decisions that you can make and getting real-time feedback on the cost as well as energy. And that's the objective, right? Like you don't want to be spending or you don't want to always look at or work in siloed workflows where you are just concentrating on one target that you're trying to optimize for. And then you have to come back and see that it is actually not matching all the other targets, which are also a focus within your project. So on the optimization page, that's the objective, that you're looking at all these product selections that you have made, making sure that everything that you want to account for or you want to take into consideration have been added to all these are added as energy conservation measures. And then you're looking at all these options that are available to you, looking at how these product combinations impact the cost premium, the energy use intensity, lead points, payback years, energy savings, and embodied carbon. And in case your project priority was a lower EUI, and in addition to that, lower embodied carbon, you can definitely create those filters and make sure that you're only targeting those product combinations that would satisfy your project requirements. And at any stage, you can always invite your project collaborators to provide more insight on the design decisions that you might be making at every step. And that's how successful collaboration is measured, right? You would basically want to make sure that you're giving the ability to all stakeholders to have a platform where they can talk across the board, talk across all these different disciplines, and make sure that everyone is on the same page and are making holistic design decisions at every stage. That's everything I had for today's session. In case you would want to know more about certain aspects, or if you have any questions, we can definitely take those now. And you can use the question and answer section in your Zoom window to ask any questions that you might have. Were there any questions? Did you have any concerns or questions or suggestions? Okay. We can wait for a minute more, and then if not, we can probably end the session. And if you have any questions, as usual, you can always reach out to us via live chat. And the live chat is present on all pages of our platform right here. You can send us a message. A real person will be answering any questions that you might have. So it's not going to be a bot. You can send us a message. Our response time is within a couple minutes. So that's going to be the quickest way of getting any questions answered. Or if you have any suggestions, all those sorts of things, we are happy to help you. Okay, seems like there's no questions at the moment, but in case there's any questions, like I mentioned, definitely use the live chat. And thank you all for your time. I hope you have a wonderful rest of the day, and I hope this was helpful. Okay, there is actually a question. How can this tool be used in data center buildings and development in terms of HVAC and thermal cooling? That's a great question. We do have some resources on our help center that would help answer that. Let me quickly look that up. Okay. Yeah. So you can definitely model a data center within Cove tool. If you have any additional questions in addition to that, we have a dedicated mechanical engineering team that can help answer any detailed questions that you might have. So in case your question wasn't answered with this resource that I just pointed out, please feel free to reach out via live chat, and we can make sure that mechanical engineers can get all these questions answered. We currently don't have CFD on our platform. Yeah, we have a load modeling tool that helps with detailed load analysis, but we currently don't have CFD on the platform. All right. Again, thanks everyone for joining. Hope you have a wonderful rest of the day, and hope the session was helpful. Bye-bye. Take care.